Okay, so Unit 3 of this course, we're starting work on polynomials, and it's a little bit of a longer unit, and I guess related to some of the stuff we did in the first unit. Comes back to that a little bit, yeah. Anyway, so a couple definitions to start. Polynomial, we deal with polynomials in one variable. Polynomial can be in two variables or multiple variables, but the ones that we do are one variable polynomials. We're going to talk about equations of polynomials as well as polynomial functions. So I guess I'm kind of rambling a little bit here, but when we talk about a function, we're going to have y equals something. The something is the polynomial part. So it does have a y in it, but that's different from what you might call sort of a two-variable polynomial. That would be like a different thing. So the point here is this definition, which says polynomial is an expression that consists of variables, so just the one for us. These ones are in terms of x. And then it has a bunch of terms, and so those terms have coefficients. Okay, and this is important. Involves only the operation of addition, subtraction, multiplication, and non-negative integer exponents. What would a negative integer exponent give us? That would give us a variable in a denominator, right? X to the negative 2 would be like 1 over x to the 2. So that is not a polynomial when you have something like that. So polynomials are the kinds of things that you see starting in grade 10 that are like x squared plus x plus 3. There's a polynomial, right? Degree 2. So that's what we're looking at for the next little while. The degree of a polynomial when it's in one variable is really easy. It's just equal to the variable, so again in x, which has the greatest exponent. If you're dealing with polynomials in multiple variables, it's a little bit more complicated. You've probably seen that at some point, but when you're dealing with just one variable, it's fairly easy. So if we take a look, this is a general polynomial of degree n. And so here is the term with x to the n. So that would be the largest exponent in that term. And the a with a subscript n is just referring to the coefficient of that term, right? And then you line them all up, and you add them all up, or if the coefficient is negative, then you'd be subtracting. So if a2 happened to be negative, then you'd be subtracting. But otherwise, you're adding a bunch of terms. Does that make sense? And again, you've seen lots of these in degree 2 from grade 10, and then again in grade 11. And something that's important is an, in this case, is the leading coefficient. So it's the coefficient of the highest degree term, and that's important because it's going to tell us something important about the function. So when we start talking about these as functions, again, if you remember back to Unit 1, we talked about end behavior, and we talked about interval of increase and decrease, and I described it as like these are all characteristics that you use to describe different functions, just like you would describe the characteristics of a person that you met if you were describing them to somebody, brown hair, blonde hair, whatever, right? Same thing. So that's what we're going to do. We're going to look for those clues that are in the polynomial, in the equation, in the graph, that kind of thing, and understand how they relate to the characteristics. Eventually, that's what we're going to do. Okay. So first question. Determine whether each of the following is a polynomial. If it is a polynomial, state its degree. So does the first one meet the definition of a polynomial? Might seem kind of strange at first, but yes? Yeah, very good. Is the next one a polynomial? Not a polynomial, that's right. C, is it a polynomial? So C is like a classic polynomial. It's got a bunch of terms that you're adding together. Okay, so it's got a y over here, but again, we could write that as f at x, so this is a polynomial. Like, if we ignore that part because that's the graphing part kind of thing, we call this a polynomial, one variable. And be a little bit careful once in a while, the textbook, or, you know, maybe even I might do it, throw one of these at you where it's not written in the right order. And that is such a nasty trick, but you do have to be careful and pay attention. So just make sure, it looks like it's degree 4, but check to make sure it's written properly, and it certainly is. There aren't any higher degrees hiding. And so this one would have a leading coefficient of 5. The fact that it's a 5 isn't necessarily so important, but the fact that it's positive is not yet, but that's where we're going, right? So, and then this one would have the first one would have a leading coefficient of 1, again positive. Okay, D. So D is a polynomial in 2 variables, but would not count as a polynomial in 1 variable. So for us, not really. It's not a polynomial in 1 variable. And if you rearranged and solved it for y, okay, then would it meet this definition in which all of involves only operations of addition, subtraction, multiplication, and non-negative integer exponents. Non-negative integer exponents. If you rearrange that for y, it would end up with a square root. A square root function does not count as a non-negative integer exponent, does it? It's like exponent of 1/2. So would not count. Okay, next one, 2 to the x. So exponential function, does that count as is that a polynomial function? No, definitely not. And what about trig functions? No. Pretty straightforward. And if you think there's something deeper to this, there isn't. And as we practice, as we start getting into and doing some actual work with polynomials, this will be very easy. Like, recognizing a polynomial is very easy. There are a few other definitions that aren't written here that I would suggest you read. I think it's on page 124 of the textbook. I'll look it up and let you know for sure. But I think it's page 124 of the textbook. And it talks about a couple other things, like the domain of a polynomial function is always x is an element of the real numbers. A couple of different things like that. So other things that could help you recognize a polynomial function, something like that. But I'll leave that to you to read through some of those other details. Okay, but they will be things that you would be required to know. But it's very straightforward. Okay, and the only other thing we're going to do today is take a look at finite differences, which are very useful in polynomial functions. So the finite differences, remember, are differences between successive values of the dependent variable, which typically we call y. So, and when we say successive values, we like it that x's are counting by 1s. They have to be counting by something consistent, in which case we find the difference in the dependent variable, and that's your finite differences. So who remembers, for a linear relationship, what would we know about the finite differences? Kind of a random question, but Hunter? For a linear relationship, the first differences are equal or are the same. All the same as each other. Good. And then for a quadratic relationship? Good. And what's the degree of a linear relationship? Yeah, and what's the degree of a quadratic relationship? 2, right? So first differences of a degree 1 are all equal. Second differences of a degree 2 are all equal. So what do you think is going to happen as we continue to go up? Indeed, if it's degree 3, if it's the third differences that are all equal, then you have a degree 3 polynomial. If it's the fourth differences, degree 4, and so on and so forth. Okay? So in grade 9, you learn about linear. You learn about degree 1. You learn a fair bit about that. In grade 10, you learn a fair bit about degree 2. And then in grade 11, you learn about all these other kinds of functions that we reviewed a little bit in Unit 1. And now we're basically going to learn about all the other degrees. So they're all a little bit like different, but there's patterns. And in general, we're gonna sort of learn those patterns and those characteristics. So degree 4, degree 5, and then we can extend that to and degree 3 to 6, 7, 8. Like we're gonna learn things that are gonna be true about all of those. Okay, so eventually you start to get these patterns that happen as the degrees get higher. And so that's at least what the beginning of this unit is all about. So 4, finite differences. Let's start doing this. 8. So these are going up consecutively, right? 1, 2, 3, 4, 5, 6. So 8 minus 1 is 7. And go ahead and keep going. So no pattern in the first differences. So we keep going. No pattern in the second differences. Well, there's pattern. You can see what the pattern is, but we're going to keep going and just show that, okay, so up 6, up 6, up 6. If you got a negative result, obviously you would put that it's a negative result. So there's your third differences. Therefore, degree, use finite differences to determine the type of polynomial function that could model the following relationship. So therefore, degree 3. Because the third differences were all equal. Pretty easy. Any questions? We got that okay? Try one more, give it a shot. Okay, and again, I found that the third differences were equal. So this one's degree 3 as well. There are, if you've seen when you get an exponential relationship, that there's a pattern, often at least, an obvious pattern, I mean, in the first differences and second differences and so forth. In grade 11, you talk about the ratio, so you don't find the differences, but you find the ratio from one to the next, right? And then that becomes consistent. But finite differences are really important for polynomial functions because when they have, like, you can find the degree of it, and they will eventually, the finite differences will be equal of a polynomial function. So they're very closely related to that. We might be able to get some kind of a pattern for other functions, but really first differences, or finite differences, sorry, are for polynomial functions. So page 127 is some homework, is some practice on that. It is quite straightforward. There's not a lot of work there. There's not a lot more to this than what we just saw. But page 122 has some review of factoring. So you need to be good at factoring, just like in grade 11, you need to be like quite fast at it. And something that we're going to do in a few days comes back to factoring. So you're going to be factoring some quadratics, but we're going to factor other kinds of stuff as well. Okay, so there's some kind of review there that you can do at least sometime, I would say, this week.